Welcome to Rocky Broad Solar, where we encourage you to make the current flow. On today's episode, we're going to be wrapping up all the final details in preparation for our final inspection here. Again, when you're going to call that final inspection, you need to have all your I's dotted, all your T's crossed, because as soon as the inspector comes in here and starts seeing little details here and there that are off, they're going to start picking your work apart. So what you need to do, they need to come in here and just see everything's perfect the first time, know that you're a professional, and they don't have to look any further. So some common reasons why you're going to fail a solar and storage inspection. One is going to be stickers. The National Electric Code requires just an obscene amount of stickers plastered all over your electrical equipment, out by your meter, on your disconnects. It's ugly. It's going to make your installation not as appealing, but it's just required per the National Electric Code. So we're going to go through those later in the video. But you are going to need a warning photovoltaic power source sticker at least every 10 feet along your DC conduit, your DC PV power source circuit up to your solar panels. You're going to need a bunch of stickers on your inverter with the DC disconnect rating, just warning stickers. You're going to have some energy storage system disconnect stickers. Out on the AC disconnect, we're going to have some stickers. We need a rapid shutdown sticker out there. And then on the meter, a couple warning stickers, just letting everybody know when they walk up. They're going to just see nothing but bright stickers everywhere and know, hey, something's going on here. Looks like we've got solar and energy storage, so you better watch out. Next, you're going to want to make sure all of your holes into the home are sealed up with either caulk or some duct seal. You're going to want to just do all the little stuff like, clip all these little zip ties and make it look nice and clean. You're going to want to make sure all of your breakers are labeled. That sounds small, but you're going to fail an inspection every time if you're not labeling your breakers. Right here's a hole in the dead front cover where somebody could stick their finger in there and get electrocuted. Right, we're going to need to plug that with either a spare circuit breaker or a little breaker cover. I prefer spare circuit breakers because those little plastic covers tend to fall out when you take the dead front covers off and on. I got to get all my covers on my LBs. A bunch of those are open at the moment. Any wire or conduits got to be supported per the National Electric Code. So Romex, it's like every 3 feet. Flexible conduit, most of it's every 3 feet. EMT, at least 3/4. You're going, once every 10 feet, or I think 3 feet from a termination. Little things like that. Get all your stuff strapped, secured, stapled, labeled. If you have any knockouts busted out that were unused, you need to plug those with a knockout hole, a knockout cover. If it's outside, that knockout cover's got to be watertight. So this is a 5-pound block of what's called duct seal. It's a great option for plugging up holes. Like here, my holes were oversized, bringing the conduit in. It's just like a cheaper, more solid option than, say, caulk or something of that nature. So I'll go ahead and leave a link down in the description. This can also be used to plug conduits going in and out from different parts of your area. A lot of people will stick this up in the rooftop junction box to plug the hole going down the conduit, or sometimes even in areas like this where it goes in and out of the building. I don't personally do that. I just don't think it's necessary. Press it in there real good. so that you get a nice watertight seal. No water's gonna get in, no critters are gonna get in. And again, it's the little final touches like this that make an inspector show up and just feel like you're doing a good job. Alright, so one thing everybody's going to want in their home is some type of surge and lightning protection. That's obviously not going to protect you from a direct strike. There is lightning protection systems that you can have professionally installed, but that's not what I'm talking about. I'm talking about lightning hitting, 100 yards away, causing a surge to come into your home, whether it be from your DC conductors or your AC conductors or what. So now I've already got a first surge whole home surge arrestor out at my utility meter. That is required per the National Electric Code for any home that's working on the 2020 NEC or later. And even if it's not required by code, you just want to have it. To this day and age, you have so many sensitive electronics in your home, whether that be GFCI outlets, arc fault breakers, little circuit boards in your kitchen appliances or in your HVAC system. And when things like trees fall on power lines or utility workers are working on the line, things just happen. Surges happen. They send surges in from the grid into your home. And you're going to be stuck paying the bill. The utility's not going to be liable, and they're not going to own up to it. So what you need is a whole house surge arrestor installed right at your main service panel as power comes in from the grid. So my main concern is when the power goes out, the GridBoss is going to disconnect from the grid. And if some type of surge happens at that time, my home is no longer protected. Some types of surges might be like hooking a cheap standby generator up to your home. Like, for example, in my house, I've used a little portable generator and a manual generator interlock kit here, where I can flip my main off my critical loads panels, flip my generator breaker on, fire up my little standby generator, and run my backed up loads. Right? But that generator is supplying dirty power into a lot of sensitive equipment here. And really, I want to protect this panel from surges and from dirty power. Now I am going to be hooking up the EG4 Chargeverter, and I'm going to be converting that generator over to charging my battery bank. But I am probably going to leave this generator interlock kit in place just as another form of redundancy, so that I can, in fact, worst case scenario, disconnect this panel from everything else and run it on a standby generator. So I was pricing out whole home surge arresters for my backup panel here. And, I just went ahead and decided to go ahead and get an EMP shield. It provides the same protection to your home, but it's also rated for protecting your home from an electromagnetic pulse. I'm sure many of you already know what that is, but that can be related to solar events, or that could be due to a nuclear detonation in the Earth's atmosphere. The number one thing that any inspector is going to be looking at when it comes to your house is grounding and bonding. They're going to want to make sure every piece of metal throughout the entire system is grounded and bonded. In this case, I probably should have punched some holes in the back of my gutter before I mounted it, but I didn't do that. So I'm just going to go ahead and mount this through the bottom of my gutter. I don't see any harm in doing that. But essentially, this gutter is kind of like the intersection of all my electrical components, and I am going to go ahead and just do an official bond between all my components, just to make sure, again, everything is grounded and bonded. There's no question to the bonding of the system. So I've got this ground lug or ground bar kit. You can buy these at any electrical supply house or online. I'll go ahead and link one in the description. Also, this is what's called a tap set. I'll go ahead and link that in the description as well. Essentially, this is a nice tool to have. They're essentially just drill bits that are both a drill bit and have threads, so you'll both drill it and thread it in one shot, and that will give these bonding screws here something to thread into on the gutter to create that bond between the metal and the ground bar. Alright, so I don't see anywhere on here where it says the width and the thread count of these screws. So what I generally do is just find my tap set. Again, these are going to be different diameters and different amounts of threads per inch. And so I'm just going to try to find the one that aligns with mine. Alright, so again, I'm just going to hold this up. I'm going to kind of look at it from both sides. And in this case, the diameter matches and the thread counts match. So this is my tap set that I'm going to be using. It's a 1032. I'm going to mount this probably as far back to the back as possible and keep it out of the way. I should have just marked the metal enough to see where I need to drill. You're going to want to go slow so that once you punch through, you're just going to thread it and you're not going to run the thing all the way through and strip it out. Alright, so the drill bit is through. Now we're going to thread the metal. I'm going to go real slow here. Alright, and that's through. That's it. Now we're going to just back it out. Alright, we're through. Now we're just going to gently back it out. Line them up. Just kind of get them started by hand. Don't want to over tighten, just kind of snug them down. There we go. If you all are getting value out of today's content, do me a favor. Hit the like button, subscribe, press that notification bell, or leave a comment down in the description below. Let's get back into it. Alright, so some of you may have seen the episode where I tested the rapid shutdown switch and it actually turned off my critical loads in my home. I did have a viewer that pointed out that maybe because I didn't have grid assist set up when I turned the inverter off or on or hit the rapid shutdown, that the house's power goes out instead of instantaneously pulling from the grid. It shuts down for about 10 seconds and then comes back on. That resets my internet. It's kind of annoying. It resets all the clocks. And most systems will just seamlessly trip over to the grid immediately within milliseconds. You can barely see your lights flicker. And we're going to go ahead and test today whether that's the case now that I have allowed grid assist in the app. Well, it looks like that didn't change anything, unfortunately. I'm not sure why the rapid shutdown switch cuts off the backup loads, but it seems like it just does, and that's a function of this system. I'm going to go outside and disengage the rapid shutdown switch. There you go. Really just all that happens when you hit that switch. It cuts off the batteries, it cuts off the high voltage DC with our Tigo rapid shutdown system. And that's pretty much it. For whatever reason, it cuts off the backed up loads panel from grid. In order, basically it pops these inverter or these battery breakers. So in order to re-engage them, you're gonna have to just press that little switch there, the little button on the battery itself, and then disengage and re-engage the breakers. I swear last time it tripped some other breakers in the system, but in this case I don't see that today. Alright, so since I'm going to be working with the DC bus bars, we're going to go ahead and shut everything down. I'm going to go ahead and turn off the FlexBoss breaker. I'm going to turn off the batteries. I'm going to turn off the battery breaker in the inverter. I'm gonna go ahead and turn off this backed up loads disconnect and turn on the grid bypass, and I believe that's going to allow grid power to pass through to the backed up loads panel. Alright, so I've got my battery switches off, I've got my battery circuit breakers off, I've got my battery disconnect off here, I've got my DC disconnect off for the solar panels, I've got my FlexBoss breaker off here in the GridBoss, I turned off my backup loads breaker and I turned on the grid bypass. That did in fact allow me to pass utility power through the entire GridBoss to both my non-backed up and backed up panels. So in the event that again you got a rapid shutdown event or you've turned a bunch of stuff off, using that grid bypass is going to be an easy way to just get power to your backed up loads. Alright, and now that we got everything off, again before we start messing with anything, we are going to verify with a voltmeter. So first, I'm going to go ahead and turn it to volts DC. That's the little straight line with the little dashes on it. And again, it just bounces around a little bit between a few volts, but we're going to go ahead and throw it on our battery bus bars here between the positive and negative. Saying I got 12 millivolts, which is essentially nothing. We're going to check our battery terminals up here. I've got 45 millivolts. We're going to check our PV conductors. I got 0 volts. We're going to check all of our MPPTs. 0 volts. This one's got 12 millivolts. Let's go ahead and check, you know, ground to neutral. 0 volts. Ground to hot. 7 millivolts. Ground to negative. A few millivolts. I think it's safe to say we're good to work on this. So we're going to go ahead and start by pulling our ground from the batteries over to our terminal block here in the wire gutter. Now, I'm personally working in this panel while it's hot. I absolutely do not recommend anyone at home to do that. I am a master electrician in the state of North Carolina, and I personally feel comfortable with it, but this is not best procedure. It's just what's convenient for me today. Again, working in a live panel is extremely dangerous. I don't recommend anyone at home to do it. If you touch anything exposed in here behind the dead front, such as that bus bar, the main lugs, the terminals on these circuit breakers, it could be instantaneous death. Now, for a lot of you, this may seem like overkill, and to be honest, it is. You really only need one equipment ground per enclosure, but you know, I just feel like you can't have enough grounding and bonding, so I'm going to kind of just ground all equipment into this gutter. Here's Bertha, our resident black snake. She was in the basement when we moved in, and I pulled her on out of there. She's made her way back in the house a couple different times over the years, but she just seems to really like this house, so she's been hanging around ever since. She's a biggin'. Alright, so to connect the equipment ground to the ground screw on your battery, looks like in my case I got number 6 wire, so I'm going to use a 6 1/4 inch lug. I guess, you know, the 1/4 inch is the important part depending on the equipment ground you use. My opinion, 6 should be more than sufficient. We are sort of doubling up. I don't think you can see because all these wires are in the way now. Probably should have done this originally. But it's already got that little jumper from this conduit box over to that lug. So we're going to kind of be doubling up some grounding lugs here. I don't really see an issue with it, but technically it could be a code issue. I don't know that you can kind of double up terminals on one single ground screw. tells me that's just not going to be tight enough. This is a 6 die, 6 gauge wire. It's a 6 lug, but it seems like these have been a little loose. Yep, this one is as well. So we're going to go ahead and bring the die down to a number 8 die for this one. I think it really depends on the lug and the thickness, if it's, you know, plated or not. But for whatever reason, or maybe it's just these Chinese dies aren't actually 6 gauge. You know, it seems like they don't match up between different manufacturers. So, all right, so I'm going to go ahead and ground the batteries. Now this is, you know, they've got the little ground screws back there in the back, but you know, the instruction manual tells you to run a little jumper over there from the conduit box. And to my knowledge, you can't land a bunch of different ground terminals on the same screw. You can on a ground block or a ground bar. I don't really want to install a ground bar here. I don't think it's necessary. And the screws that go here to keep the case on, I mean, to me, that would make the same bond as those green ground screws. So hopefully the inspector agrees with me. I'm going to go ahead and use these screws in the front to ground everything. One thing a lot of inspectors might want is for you to bring some bare metal to bear there. So I'm just going to grind off that powder coating right here where I'm going to be connecting the ground screws, and we're going to go from there. The camera died when I did this other lug. I'm going to go show you how I do that. What I'm running into here is I've been using a 6 gauge to 1/4 inch lug. This is 6 gauge wire for my ground. It is a 1/4 inch screw that this is bonding to. But what I'm running into is the 6 gauge crimper, or the 6 gauge die on my cable crimper there is too big. Once I crimp that, the lug will slide right off. When I use the number 8 die, it gives it a nice solid crimp, but it kind of fillets the lug out like a butterfly. And so on the next ones, I'm going to try to use that 8 gauge lug, but just not quite cinch it down all the way, and see if that helps at all. Otherwise, it just is what it is. This is a good connection. It just kind of looks a little shady. Alright, lastly, when it's time to come for your final inspection, make sure you print out a bunch of nice pretty pictures of all your roof work. Most inspectors aren't going to get up there on the roof. They're going to be reliant on the fact that you have documented all of your work. Again, those rooftop junction boxes, all of your connections, all of your grounding on your racking. You got a nice tape measure pulled in between attachments with some nice pretty pictures showing the attachment lengths and spans. Just so that way they show up, have it all included with your approved design. Any engineering stamps here in North Carolina, we both require structural engineer stamp to get that design through permitting, as well as an as-built stamp saying that yes, you have installed the thing per the manufacturer's recommendations. Have all that stuff nice and printed out in a nice folder. Keep your actual permit in that nice inspection pack, so that way when the inspector shows up, he's got everything he needs right there. The permit, the approved plan set, all the engineering documents, a bunch of nice color photos of all the installation where he can't see. And that way, again, you just make his job nice and easy. You look like a professional, and he walks in there and he just finds someone that knows what they're doing and knows the procedure, and signs off on that installation the first time around. Again, I really appreciate each and every one of you for watching. If you're interested in an EG4 products or any other solar and storage products, go ahead and check out the affiliate links and coupon codes down in the description below. You might be able to save yourself a little bit of money. If anyone out there is just DIYing this stuff, hey, it's a lot of work. It takes a lot of skill and a lot of time. Maybe that's really not your cup of tea. If you're just looking to hire a professional installer to come out to your home, install solar and storage on your home, go ahead and go down in that description below, click on that Rocky Broad solar intake form, just fill out a few questions about your specific scenario. We'll get back to you within a few days with a zero cost, pressure-free quote. Then sit down, have a quick 10-15 minute conversation and customize that proposal for your specific needs. Again, I really appreciate each and every one of you. Thanks so much for watching. Till next time, take care.